This is a Juncker's calorimeter, which gives the amount of energy released by burning a known volume of gas. This video will show you how to use a Juncker's calorimeter. It is fueled by natural gas and is cooled by tap water. It's basically a Bunsen burner with a cooling jacket. The gas is controlled. There's a tap back here which turns it on. You will have to turn the gas on first, but it is also controlled by a rotameter, which is the control for how much gas is coming through. And we'll light this, and then it will sit inside the chimney. The chimney is actually lined with cooling water tubes, and I'll turn the tap on. The water comes into a constant pressure weir here and flows down. Some of it flows through the cooling water, the tubes, and then comes out through this side arm. We will be able to collect this water in a bucket. There are two thermometers up top, which gives us the temperature of the incoming and the outgoing water. Let's try lighting the gas. Wahlberg 208 is one of the very few rooms in the building that actually has natural gas service, which is why the instrument is in here. You need to turn the gas actually on to the entire room here using this nozzle. Before you leave, make sure that you shut it off again. We'll need to turn it on so that we can use the apparatus. Turn the gas on and have a match ready, and then open the rotameter and get about 50% flow. Strike a match and fly. That's not very visible. If I cover it, you should be able to see a nice yellow flame. However, you want the gap at the bottom to be letting air in, so we've got an almost invisible blue flame here. This blue flame and the entire burner needs to go inside. At this point, it goes underneath and up like this, and the screw attachment fits onto this side leg here. Open it all the way up. Put it on so that you can see the leg coming out, and attach the screw. And that now stays in place for the rest of the day. You can look, we have a mirror here, to look up the chimney to make sure that you still have a flame. Sometimes this goes off, but if you can see a blue light, alternatively if you cover this over you'll see some yellow, you will be able to get evidence that the flame is still in place. Once we have got this going, you need to let it sit for about 10 or 12 minutes for the system to equilibrate. As natural gas burns, it produces CO2, which is a gas, of course, and it produces water. And the water at the temperature of the cooling jacket is a liquid, and so it will start to condense. It takes a while for this to happen, but this nozzle here, not the one with a tap on it, but the open nozzle here, is where the condensate will start to drip out. Until you have dripping from this nozzle, there's no point in taking any readings. As I said, it takes about 10 minutes. Once you have got this equilibrated and the temperatures up here are stable, the incoming water will probably be around about 4 or 5 degrees. The outgoing one will be warmer than that. It's time to start measuring. The Juncker's calorimeter is a flow calorimeter. It's not a batch. So the heat transfer is taking place constantly, not in one lump. When you are ready to do the measurement, take a clean, dry beaker and put it underneath the drip of the condensate. Take a large bucket, put it underneath the collection arm, and then you can use a clock or your own watch, and for a fixed period of time, 60 or 90 seconds at T0, start collecting the water. Let that run for, as I said, 60 or 90 seconds, and then when you're finished, stop. You'll need some paper towels to catch the splash, and at that point, also remove the condensate collector. When you have water in here, use a graduated cylinder to measure how much you collected. When you're measuring the condensate, it's only going to be a few drips. So doing that by mass is probably the easiest thing to do. Weigh the beaker beforehand, weigh it with some water in it afterwards. There are two controls that you actually use. One is this knob here, which gives you either fast rate or a slow rate of cooling water going through the tubes. Now, at the moment, I've got it going very slowly. I'll have it out here so you can see quite a slow rate. I can also increase that rate so that it's running through quite quickly. When it's running through quickly, there will be a lower dwell time, and this will be cooler. If you cut it down to just a trickle, and it does need to be an actual trickle, not shut off, then there'll be a longer dwell time. It will get considerably hotter. When you make an adjustment here, check the thermometer, and you have to wait until the temperatures are stabilized before you do a collection run. You should do 2 or 3 of these runs, and you can do them back to back to measure the amount of water that went through, that was heated from the lower temperature up to the higher temperature. And using the heat capacity of water, you know how much energy it took to heat that water. You will also know how much condensate was there, and there are calculations that are involved with that. The other thing that you need to read is the natural gas rotameter. The things to measure here, this knob on the bottom of the rotameter controls how fast the gas is coming through. At the moment, it's at about 55%. You always read from the middle of the rotameter ball. If I increase it, that's up around 77, or I could decrease it and take it down to about 37. So you can also adjust high gas flow and low gas flow. And you may notice that as I change that, you will also get a different pressure. This manometer shows you 2 different liquid heights, and the difference in height, this one is around about 5 centimeters, this one is around about 12.2. So we've got 7.2 centimeters of water as the pressure that the natural gas has above atmospheric. So that will tell you the pressure of the gas. This tells you the percent flow. The calibration is 100% flow is 4.41 liters per minute at 7.62 centimeters of water. You will need to adjust that. It's a straight ratio in all cases. In this case, it was, 7.2 centimeters of water. If I increase it, it may well be more. And here it's going from 3 to 13.5, so that's 10.5 centimeters. And you also have the pressure, the percent flow read from the rotameter. And in this case, right now, it's 72, so there'll be 0.72 times the full flow. So knowing this, you can figure out how many liters of gas are flowing per minute, and that is the same minute that you used to collect water heated from one temperature to another. You will need to take readings of the calorimeter at high water flow, medium and low. You'll also need to do it at different gas flows. You should take 2 or 3 separate runs right after each other at each equilibrium point. So there are a number of equilibria that you need to reach, and you do 2 or 3 runs at each temperature. Once you have finished, you turn everything off. So the first thing to do is turn the natural gas off completely, and turn the tap off back here, and then take the burner out, and then turn the cooling water off, and last of all, turn the master gas control to off.